Basically, during the class, I have been insisting and giving you a relevance of technology platform. First, I highlighted the significance of overall the big data, and all big data resources are unstructured, semi-structured, and also coming from some of those, data sources which are machine-driven. So consider that we need to have a very, very robust platform to process them. And when I say robust platform, I'm also comparing with what we were given at the time when Hadoop was evolving. So basically, if you really go back 10 to 12 years back, when Google folks were trying to solve the problem of their page ranking and advertisement-based revenue, they were struggling to really forecast the number of users coming on their search engine. And whenever they were discussing with Oracle team on the database, because that those days, obviously the database of choice was Oracle or IBM DB2. So they were looking at how this can scale, how this can process the large volume of data which has got no structure. Because people are going to log in and the log files, how are you going to process? So always the discussion was, tell us the data volume and we will be able to process it. So I will scale up, I will add more memory, I will add more resources of CPU and disk. So, and they were not able to tell us, right? So they went back in their lab and they started asking some of those nuances that, okay, tell me about if I have a system like this. So I'm drawing a chart here. So let's say if you have, OLTP systems, right? So in the OLTP system, always you see here that main server, and then you have middle tier, and then you have all got clients, right? So these are clients which is accessing all other systems. Now, given the scenario here, the database which is given here is always is CPU intensive, and basically online transaction is happening, right? So this concept was always available because by design, database was business rule driven. 10 commandments of rules was assigned by EF code, and all the databases were designed to have the transactional integrity, to give you all high consistency and so on, right? So when you are doing this, there is concept of shared everything. So when I say shared everything, you are accessing in real time and getting the transaction processed, and all your CPU resources are process are shared. So in the middle tier, which was application which was rendered to the user. Now data was stored here on the CPU and storage on the database. So now distributed computing came in. So when distributed computing, you were also trying to put data around the different locations, and then started working on that, right? So this was well suited even today for online transaction processing, banking application, travel application, airline reservations, and you name it, right? So when you commit the transaction, this transaction is stored here, and you are able to recover and do that, right? So now consider that this kind of business processing rules were not required by Google folks, right? They were looking for something alternative. What is the alternative available? We don't need that consistency. We don't need that high-end processing. We don't need that upward scalability. So go on adding more CPUs, more memory and all that. That was the premise given by the database people, right? So they looked at in the market or academic institution, and they found that there is another technology architecture available. And now I'm drawing basically your concept of cluster computing, right? So you are now having this kind of configuration where all this is name node, right? And name node has basically, giving you the flexibility of managing all the metadata around your data nodes. Now, these data nodes are basically horizontally scalable. So when I'm saying data node is horizontally scalable, that means I can go to n number. And all the data, which is high volume, high speed, I'm a client monitoring the cluster and ingesting the data here. This main node was cluster available in the academic research institution or meteorology department to forecast the weather. So now obviously main node to provide redundancy was secondary name node, right? And now it is basically giving you that kind of resilience. If this fails, you have round tripping to go on that. And data, since this is commodity servers, that means that has got less CPU, the number of processors and resources of memory and disk. So these guys, when looking at, oh my God, this is now low cost and horizontal scalable on demand. So I can go on adding as and when I need to have more nodes. Since this is a master, right, and this is slave. So now these are slaves. So all this data nodes are slave and this is the master. So depending on what master assigns the job, this data node will perform. So now premise was that these are dumb nodes. And when the dumb nodes, they can only perform the task what you assign them. And also this is shared nothing architecture. That means when you put the job here, it will only do when it is processed, then it will take another job. So you need to bring in the job stream. However, it is a parallel processing, but it is scheduled job. You see the premise of cluster. So based on this, these guys felt who were designer, and they were able to, everything, right? So now you got that and you are able to do just 1 second. So in that respect, you were able to now bring in all the phenomenon of processing the data. Now in this scenario, which I was talking about, you can see here that shared memory does not scale nearly well, right? Enough for data scale analytics. Now I'm going a little bit on the background so that everybody can understand that. I'm sure people who have gone through the Hadoop background and training, they know that, right? For stand performance, nothing works better than putting CPUs next to the disk. So that means you're cutting down on I/O operation, input-output operation. So shared nothing design increasingly being used for petascale analytics. Now, when this was premised, then Hadoop design architecture was written. Now, another aspect I'll tell you why database is so powerful for online transaction processing. And I was just looking at some of those, that how can I put application which I have built on database, bring the relevance to big data. So here, think about compare and contrast. Database has got ACID compliance. When I say ACID, atomicity, consistency, isolation, and durability, right? So these 4 major characteristics have been enforced in Oracle database or SQL Server database or any RDBMS, relational database management. Now, if you think about transactional atomicity, meaning either whole or none. So banking people will tell me here, they will not accept anything other than this, right? Because they wanted to make sure that when transaction is taking place, either money is withdrawn or it's a rollback, right? So when you go to ATM, click on that, your money is withdrawn, $100 out of 1,000, then 900 should be shown in your balance, right? Nothing less, nothing more. This is what we're talking about, either or whole, or in between, if some network error, transactions to roll back, and you should be rest assured that nothing went wrong. Same thing for airline reservation. When unless you commit, tickets are booked, you are not going to have a ticket, right? Because it will roll back. Now consistency, the same thing, and isolation. It appears that it's for me, but it is for so many people, right? So durable, highly durable. This is what we're talking about ACID. Now consider in our case of big data. Now, what are things which is required? These things, consistency, all that, right? So we'll look at those in the design fundamental. Then Eric Brewer came and he had given a theorem. And he suggested that, look, if you're going to process anything on the clustered architecture, and remember, I just defined about name node and data node, master and slave. So he mentioned that, look, out of three, you have to only pick up two, one has to be compromised. This is what cluster computing is all about. So now, cluster computing, when Hadoop guys were building up the architecture, they said, do we need consistency? Right? Ask yourself, you are processing sentiment analysis for social data. Do you really care when I have 100 people commenting on something, 90 people comments I make the trend, right? If weblog analysis, do you think that we can have those kind of things? Now, depending on all that, you should be able to how things are working, right? So we have to appreciate the fact what are we compromising, and consistency most of the time should be compromised, right? This is the Eric Brewer theorem. Now, so how to process big data? Let me pause for a moment and take your discussions so that then I'll go and brief you about big data processing by Hadoop. Pratik, what do you think? Everybody is able to hear, and you can unmute. Everybody can hear me?
Hello.
Yes, go ahead. You can hear me, right?
Hi guys, are you audible? Yeah. So today Alak is just giving a welcome everyone for the session. I think some of you have joined a little late. So Alak just started, and I think he's covering the evolution of Hadoop and what were the basics behind and theory. So we have just started, and you can put down if you have any particular questions which you want Alak to cover in this session, you can let us know. Alak, can you just recap in 1 minute, what are we discussing today, so that all who has joined a bit late, they can know?
Sure. Yeah, so I started giving the sense of what was the compelling reason for designing Hadoop. And that came as a nudge project by Google folks, Sanjay Khemawat and Jeffrey Dean and others. They started solving the problem when there was evolution of so much of log files on Google search engine, because people were coming in there and they were not able to get predictive modeling based on that, because they were doing the page ranking and they were doing advertisement revenue generation from that, right? So I was giving what was the architecture available. OLTP based on grid base was available, and database has got all the business rules enforced, and that has got transactional integrity. So I was talking about atomicity, consistency, isolation, and durability of ACID. And then I also talked about cluster computing infrastructure availability at that time. So they evaluated that of master and name node and data nodes, and that they felt that, okay, consistency can be compromised, because for sentiment, for log file, we don't really need to have 100% consistency. Right? Now we are talking about how to process big data. Now, big data you all know, so I'm not going to talk about that. So obviously, how about dividing and processing? So now if you are given, let's say, petabytes or terabytes, so if you come to one machine server, so definitely we'll be talking about high-end storage, high-end CPUs, multiple CPUs to work on. So it will be too much to ask for any high-end server to configure to address that. So you can very well divide the work like of 64 megabyte blocks, or now 128 megabyte blocks and distribute that workload across the nodes. And you know the nodes I'm talking about, cluster configuration, right? Then combine all the workload and again get those output. Right? So this is very simple premise on which Hadoop has started working on. So they built this scalable, fault-tolerant distributed system for data storage and processing. Now, we know what is the purpose of Hadoop. First of all, you need to store. Storage on the file system because we don't want to have real-time transaction here. We wanted to have analytics. We all know the purpose of making more meaningful insights from the by volume data coming in. So they started gathering that and storing on the file system. So they created Hadoop Distributed File System, SDFS. And this is under open source Apache license. So whoever is taking that is a community based. They are enhancing likes of Cloudera, Hortonworks, or MapR. They are what they're doing. They're taking the open source, enhancing the code, and supporting the customer, charging only support fee. Right. So this is what it is. Because Hadoop Distributed File System. Then MapReduce is a distributed processing, which is your more of a programming instruction or code. When we say give MapReduce workload, algorithm, this is what you'll be playing with. People ask, what is this written on? It's primitive Java-based language. And who wrote this? So when you look at all this here, you'll find details about what I'm talking about. So it enables big data processing. Any data which is unstructured, semi-structured, and you should be able to process that. Can store huge volumes, weblog files, social media, all this kind of data, right? And massive data aggregation. Now, obviously, you need to have all those in a more scale out fashion. So when I say scale out, you don't know how many nodes you will require at the beginning. So when you ingest the data, let's say terabyte. So obviously your default size within Hadoop is 64 megabyte when they started. Now we have the recent version has 128 megabyte. So now 128 and terabyte. So once you divide by that, that will give you a number of nodes. So data center will tell you that, oh, you need this many nodes in this cluster operation. Then you could be able to manage your workload of Hadoop. Right? Now, this is what Hadoop started with. Developed from Apache Notch project, an open source engine, and then started building from there. These key guys still here around us. Sanjay Kamath is in RIP Silicon Valley and keep bouncing in the conferences and seminar, and he is a great guy to work with. Then we talk about Jeffrey Dean, also together, and Doug Cutting. Doug Cutting was the guy who was working in Apache Notch project. He looked at the architecture when these guys wrote paper. If you click the link, you'll find the paper. And he simply started saying that, oh, I can write the software now, framework. So when he was writing, he said, what should I name this? So he said, okay, there was an elephant toy, the child was playing, his son, and immediately he's called it Hadoop. And automatically, he defined everything as for what this guy is designing the architecture. The way I was describing on the whiteboard, same flow. If you read in the paper, it has been mentioned, right? And then it became shared nothing compute architecture. Shared nothing, you know the meaning of that, right? Because if I'm working on something, don't disturb me. I have my all resources deployed to process a job. When I finish, then tell me, I'll do it, right? This is what shared nothing. But on the contrary, online transaction processing, no, I can take everybody's request. Your data server or CPU centralized in some location, and bank is having so many users putting all queries and asking to give me the report or give me the transaction. So data, CPUs, memory, the storage, and database is shared everything. right? And this is the architecture for multi-user shared everything architecture on OLTP, but Hadoop is shared nothing architecture. And it is designed so because it is batch processing. I don't need it everything now. But now OLTP cannot do that. We have to have now. And this is what we say, real-time multi-processing, multi-user, and distributed environment. Process data in parallel to achieve its performance. So when I say parallelized everything, we have parallelized everything on database. We have to parallelize here as well. So all cluster nodes are processing in parallel and taking a job accordingly. This architecture has been designed for hundreds and thousands of nodes. Now you are talking big data processing, because if it is less than 100 nodes, less than terabyte, then you don't need Hadoop. Consider that. You don't need Hadoop. So obviously, when you have the large data workload, you'll consider, should I go for Hadoop? And then start putting the whole prototype and building across that. But when I say that, to do the dev and test is never done on your deployment server. You always do it on your dev and test machine. You can create your pseudo node cluster and test everything, all your codes and everything, right? Now, I will again move on and give you some sense of how we will be discussing logical framework. You have storage layer. So you are storing all the files. It is basically like network file system, Unix file system. And you basically bring it to Hadoop here on a storage HDFS, and then you have execution layer and that command operation, which is basically map produce jobs, which is written on Java language, and you should be able to execute, right? So this is, it runs on typically Linux. Now you can have all block size that are replicated. So this is now 128. So I always keep it here because you should remember when Sanjay Ghemath wrote the paper, they defaulted the block size to 64. So that means all the data workload when you bring in, Hadoop will shard it or divide it into 64 megabyte of block, which is manageable by your data node, which is manageable by your commodity servers in terms of memory and storage. Now, write once and read phenomenon many times, meaning worm. Hadoop is worm because you are writing once. You have ingested the workload on your Hadoop distributed file system, but your MR, map produced work, is iterative. You are writing one line to one set of work, jobs, running the whole process, getting some output. You are not happy with it. You are now changing your Java line of code again to have more attributes and getting answer. Oh, number is changed. So what it is indicating to you, the data scientist is more questioning, more intuitive, more imaginative, and the tool, the Hadoop developers will formulate that questions into your algorithm and write. So every time you write something, and I'll give you example, like I was giving example on sentiment analysis. When I post my product catalog, you said that I liked it. So I liked it is the expression, unstructured free flow text. Now what do you like it? So now how many people like it? This is one query, simple query, right? Out of 100, let's say 90 people like it, but that is not a good answer. What do you like it? I like the pattern. Oh, okay. How many people like the pattern of this? Oh, out of 90, only 30 people like the pattern. How about price? Oh, out of 30, maybe only 20 people like the price. So you see, every attribute you add, your answer is changing. And when your answer is changing, that is the thing which you will now take those outputs and start analyzing and putting your algorithm of modeling, right? So this is what the Hadoop is, vanilla machine kind of a robot job. It is nothing more than that. And if you see that Hadoop execution, you'll say, oh my God, this is what I'm after. You have to fine-tune your thinking skills, what I'm going to extract from the data, your articulation of the attributes, what questions should I ask, how should I frame that into the algorithm, because simple Java line of code can fetch many answers, right? And this is what interesting layer. So MapReduce is the framework to get and responsible for running a job in parallel on many servers. If one fails, you can always get on to many other replicas. And it consists of map and reduce. So first you map the whole process job and then combine, reduce, and take the unified value out of combiner, and then you put it onto your name node. So this is what the whole process is. So it is very, highly scalable in terms of doing this. So now across the racks, multiple server racks, cluster, you are scaling out and processing everything together. Now people are always asking me, why do I need HBase along with Hadoop? Why do I need Pig? Why do I need Hive? Why do I need Cascading? Because Hadoop is only this, right? MapReduce and HDFS. The moment you install Hadoop, you will be only getting this. But for the advantage of developers community, you are not all having the same knowledge and skills. So somebody is coming from SQL background, like all developers or database people from industry, they know SQL. Yeah.
Can I pause you for a second? I think for everyone, I think this slide is very important.
Yes.
Because a lot of you are always asking questions about what background is required to learn Hadoop, and based on your own skill sets, which area of Hadoop can you work on. So I think this slide is very important, and if you guys have any questions, these guys will also help you make up your mind on whether you want to go forward with Hadoop or you want to learn R or any other technology for big data. So all those who are online, Akshaya, Kash, Mohan, Suman, Pratima. So I request you guys to listen to this slide very carefully and ask questions if you have any.
Right. Yeah, one question still is coming, how it is different from database. Now this message should be home for everybody. These are two different business applications, because online transaction processing, I keep giving example, like if you are going into the bank operation runs on real-time processing, has to have the database, like credit card or your ATM operation. Your Amazon.com processing of your transaction has to be on database, which runs on Oracle database. If you go to travel ticketing, it has to be on transaction database processing. So those are given. But when you come to analytics table, think about what data I'm dealing with. I'm not dealing with the transaction data stores most of the time. I'm dealing with unstructured data, which is social, Facebook, Twitter, or any other type of data which can give me sentiments or behavior of customers. Log files which is coming in basically from your web browsing patterns. So what are you browsing on my web? What pages are you looking at? How much time has all that will come from the log files. Then I'm talking about some other data files. Let's say customer call data records, CDR. Customer is talking to you on the phone, or customer talking on the web forms where returns are taking, and you are taking the feedback. All that we understood. So now when those data sets are there, this is what the framework will help you. Now I was talking about Hive. Hive is complementing Hadoop, right? So it is, you think about interpreter. If you don't understand Java, I will interpret, right? So Java line of code is interpreted in SQL. So now I will use the same select statement, and those are converted or interpreted in Java line of code and will be communicating to HDFS. Pig, and Pig Latin is more of a data flow. So it's a scripting language will have the orchestrated data flow to drive your whole processing accordingly. Cascading is if you are a Java level programmer but not so skillful. Cascading simplified. So now you are looking at some of these tool sets which can help you be more efficient. And consider these all comes with Hadoop ecosystem. So when you download Hadoop and set up, or don't download, go to Cloudera version, Cloudera, get access from their instance. 1 month trial instance access they give for entire Hadoop. Go to Hortonworks, they may be able to give you access of, and you say that you're researching or a student or evaluating, they will give you access of pre-configured setup, and you start working with all these tools. Now, you know yourself. Now, I cannot say that you should have Hive. I don't know whether you have Java background or you have a SQL background or what you have. So go and introspect yourself and get those tools so that now working within this would be easy for you. Now, HBase is a columnar database or key value store to abstract all your output and put it here so that it becomes easy to manage and query those output. So this is what has been given as an ecosystem there. Now further, if you see here, the Hadoop framework, I was explaining that Hadoop is such a platform which is required on a data center level, because remember 100 nodes and above, then only you should